now we're going to cover multiplying polynomials. We've covered adding and subtracting polynomials and recognizing different types of polynomials. So this is the next logical step. On this problem, we have a -4 being distributed or multiplied into the quantity x plus 1. So the first thing we're going to do is recognize that we have a negative sign out front, which means when we are distributing this in, all of our signs here will flip and become the opposite. So when we have -4 times x, we end up with -4x minus 4. That's all there is to it. This one's nice and simple. They do get a little bit harder. Alright, so for our second one, we have 6, well, let's not do any other variables, let's just call it 6x times the quantity 2x plus 3. So what's different about this one? We're distributing in the term 6x, not just the 6, not just the x, not at separate times. This whole term is being distributed all at once. So how is that going to change it? Well, we're going to distribute in 6x times 2x. That's the first one. And we're going to do it again. Now we're going to bring the sign for this one, and we're going to have plus 6x times 3. So now let's go ahead and multiply it out, and we're going to have 12x squared plus 18x. It's pretty easy too. Just one more thing to pay attention to. Make sure you recognize that you're bringing in the x or the variable with the constant here. So it is an actual polynomial term, and this will affect any other variables you have, and constants will add a variable to them. Alright, now let's move on to a special case. And I'm sure everyone that's watching this video at this point in their life has heard of foiling. And that is when we have polynomials being multiplied that look like this. So you can FOIL only when you have two polynomial terms per parenthesis and you have two parentheses. And what we have, the little device we have to remember is first, outer, inner, last. So let's cover that real quick. So we have our first, let's do it in red. Our first terms in each polynomial expression. So we're going to have 4n times 2n. Then we're going to move on to our outer. It's the 2 on the outside. Seems, pretty straightforward. And we have a plus. We're going to add them together. So we have 4n times 6 plus inner. Well, the 2 on the end are in the end side. The inner, we have 1 times 2 in 1. I'm just going to write 2 in. I don't think we need to go and make it any more complicated than that. And then of course our last terms. Well, this is the last in the first expression, and this is the last in the second. So I have 1 and 6. So I'm just going to put plus 6. Alright, so now we're just going to come back through. We have n times n. We will end up with n squared. 4 times 2 is 8. Plus, and now we have 4n going times 6. 24n. And these two we've already done the math for because they were very simple. Multiplied by 1. And now we can look and say, well, do we have any like terms to combine? We're going to mark all of our n squareds here with red, all of our first power with green, and our constants with this light blue. Well, I have 2 greens, but only 1 red and 1 light blue, so I have nothing to combine here. I'm going to add these two together, 26n plus 6, and that is our final answer. So that's the FOIL method. It only works when you have two expressions, two parentheses, or two expressions inside, or two terms inside one parenthesis times two terms inside another parenthesis. Now here's another method we can use, and we're going to use this on the final one too. So I'm going to show it to you twice before we move on, but it's more of it looks more like traditional multiplying, so it does help a lot of people pick it up really quick. So I'm going to rewrite our original problem, 4n plus 1, 2n plus 6. So let's just take a little aside here and say, well, let's say I gave you 4 times 6. Well, you can do it the way we just did it, horizontally, and have 24, or you could rewrite that as 6 times 4, right, and get 24. Well, we've kind of looked at it this way. Now we're going to look at it this way. So let's do that. So I'm going to start with, and it doesn't matter, multiplying can be done in any order. Let's not put an X. Sometimes, especially on the longer ones, you get carried away and you kind of include your multiplication sign with your problem instead of being done and having it marked as your operator. So now we're going to have 4n plus 1 times 2n plus 6. And what I like to do, especially when I'm first introducing, is I'm going to have a constant column. I'm going to have a first power column. I'm going to have a second power column, and I'll usually put a third just to be safe. Now I'm using X here because this has no bearing on the problem. This is to help me organize what I get while multiplying. So I have 6 times 1, that's a constant of 6. Now I have 6 times 4n, we're going to use the whole term, and that's going to give me 24n. 24n is to the first power, so I'm going to go ahead and put it right here. Well, I have nothing here. Well, I have 2n now that I'm multiplying, so there's no way I'm going to have a constant. So I'm going to go ahead and put a 0 there. And at the end of the day, we're going to add all these up. So now I have 2n plus 1. Well, that's 2n, and that's a first power. I'm going to have 2n times 4n. Well, n times n is n squared, so I'm going to go ahead and write it here. And 4 times 2 is 8n. So we are here. Now all you have to do is simply add down 6, 26. Make sure you bring your variable with you. 8n squared. Same answer, 2 different approaches. I like the FOIL method on these special cases, but if you're more comfortable with the second approach I've just shown, go for it. It's great. It works. It can be just as fast as any other method. It's all really up to you and what you feel comfortable with during the test. Okay, so our final one, we have 7x minus 3. And we have x squared minus 2x. Now, if this was the end of the problem, we could FOIL it out, just like we did, or do it vertically, whatever you prefer, but we are going to add plus 7. So what do we do now? Well, you can go the traditional way, or what some kind of now feels like the long way, where you can say, well, 7x times x squared, 7x times this, and go just like that. And we're going to do that because it's best that you see every possible way to do it. So first I have 7x times x squared. X times x is going to give me x to the third. 7 times the understood 1 gives me 7. 7x times negative 2, we're going to do the entire term, times negative 2x. Well, I have x and x, so I know I'm going to have x squared. And I have a positive times a negative, so I'm going to put my minus sign. 7 times 2 is 14. And then I'm going to have 7x times 7, only one variable. So I'm going to go ahead and put my x, both positive, so I can do plus, and 7 times 7 is 49. So now I have 1, 2, 3 terms, and that should match what we have in our second parenthesis. 1, 2, 3 terms. It does. So I can move on to the next part, and we're going to make sure to include our sign. We have negative 3, and we're going to multiply that in. We have negative 3 times x squared gives me negative 3x squared. Negative 3 times negative 2, we only have x, so I'm going to go ahead and put that down. We have 2 negatives, so I know it's going to end up being positive, and 2 times 3 is 6. And then I have negative 3, a constant, times positive 7. Negative times a positive will be negative, and 21. So now we can rewrite in descending order, which I definitely recommend because it does help combining like terms tremendously. So that's our third power. We're going to go ahead and cross it out. I'm going to look for anything in the second power. Well, we have negative 14x squared. We have negative 3x squared. I don't see anything else, so I'm going to use those two next. Minus 14x squared minus 3x squared. And then we're going to move right down to our first power. Well, that is 49x, positive 49x, positive 6x, plus 49x plus 6x. So we can cross those out. And all I'm left with is my constant of negative 21. So now I can look and say, well, I have 1x to the third, and I have negative 14x squared minus 3x squared. That is my next set. There's all of our first power, and here is our constant. So I'm going to go by the color underneath them. So I only have one red, 7x to the third, minus negative 14 minus 3, negative 17x squared. 49 plus 6 gives me positive 55, and we're at x to the first power, and we only have one constant, so we're going to bring it down. That is our final answer. So during the test, something I want to talk about, we are only going to have that one black marker on that board we cannot erase on. So we're not going to have all the benefits of these colors. So maybe we can do straight line here, a square, triangle, and maybe a pentagon. So that's just one way to organize it, because now we can just combine by shape and then just come back through as we use them and cross them right on out to make sure we're in the right order. Alright, now let's do this same problem again, but we're going to multiply it vertically. And just like if we have here 21 times 7, well, we can do it horizontally. We will have 147. Or we can, nobody really wants to work a problem like this. It's always better to put your term with more place values on top. So we can have 7 and 14. Does that make sense? So that's exactly what we're going to do with polynomials. Oh, that's very interesting. Alright, so here we go. We're going to rewrite the problem, but this time we're going to put the larger polynomial expression on top. X squared minus 2x plus 7 times, and we're going to use brackets again so we don't confuse our operator as one of the variables, 7x minus 3. And I'm going to go ahead and make my organization chart constant, first power, second power, third power. Alright, so we're going to start with negative 3 times positive 7. That's going to give us a negative 21. Then we're going to move on to negative 3 times negative 2x. Well, we only have one variable, so we know we're going to be in the first power. And we have a negative 3 times a negative 2. That's going to give us positive 6. And then we're going to move on. We have negative 3 times x squared. One variable, it's x squared. So there we go. It's that easy. So we're going to verify we have 3 terms. 1, 2, 3. So we can move on. There goes that funny line coming back. So now we're going to do 7x. Well, we already have an x in the term, or a variable in the term we're multiplying by. So we know we're not going to have any constants this time. So I'm going to go ahead and put a 0 there just for ease later on when we're adding down or adding vertically. 7x times 7 gives me an x here and a 49. That's positive. Then we have 7x minus times negative 2x. Well, x and x is going to give me in the x squared column, and that would be negative 14. Now we have 7x times x squared, giving me 7x to the third. Now, here's the nice part. We don't need to rearrange them in descending order. They've kind of done that themselves naturally through this process. And now we've added down here. So now we're going to come to the second power column, and we have negative 3x plus negative 14x, giving me a negative 17x squared. We're adding, so our variable is going to come right down with the same power. We have 6x plus 49x, both positive, so we're going to end up being positive 55x minus 21. That's really all there is to multiplying polynomials, a scary subject that is actually pretty easy. If you have any questions, leave them in the comments or email me. And look for worksheets available in the description link box. If they're not there yet, I just haven't created the worksheet.